Hello, my name is Deepak SHIRBHATE. I am working as a principal of Vikramshila Polytechnic Darapur, Taluka Daryapur, District Amravati, Maharashtra State of India. And today I am going to demonstrate you VRML rotating frames, square frames using Vivaty Studio. So we are going to create the structure like this, and these frames will be rotating about their axis. So this will be the word which is simply used to create something colorful. Orientation interpolators slowly spinning 9 frames, each with slightly different speed. At first there is a clear structure, but as the animation evolves, the structure dissolves in chaos. If you wait long enough, they shall all get back in sync again after about 560 years. Things to experiment with. Try using other time key value for a rotation speed of 9 square. If the key value are multiples of a common factor, the square will get in sync sooner than if they don't have a common factor. So here actually we have increased the animation time by only 1 second in every frame, but you can try different time frames like say 2 second, 3 second, 4 second, like this, and then you try that whether they are syncing back again or not. So this is what we are actually expecting. As soon as we will click the frame, so animation will start, the frames will start rotating, and there is a slight difference in the animation timing of each frame. The first frame is having an animation time of 10 seconds, the second frame is having the animation time of 11 seconds, and likewise every frame is having animation time in the increasing order, like say 12, 13, 14, 15, 16, 17 and 18 seconds. And that's why you see such type of colorful animation. So this is what we are expecting. Now for creating such type of animation or such type of effect in VRML, first of all we will create a square frame. So draw a square frame of 2 by 2 mm, wall thickness 0.1 mm. So inner square is having the dimension 1.8 into 1.8 mm. Depth of extrusion will be 0.2 mm. We will export this file into 3D Studio format, that is 3ds format from AutoCAD with default option. So we will export the file into 3ds format with the default option, and then import the file into Vivaty Studio. It is just for export and import because there should be some common method of import and export. That's why we have exported the file in 3D Studio format. So we will just try to import the 3ds file. I have created the file and saved it with squareframe.3ds, and I am importing it into Flux Studio. Now by default there will be 6 viewpoints. I'm deleting all the viewpoints and I'm keeping one viewpoint which is of most importance because it is perfectly at the center of the frame. So I will be using this viewpoint. Now instead of black background, if you want some different background, you can create a background node and you can have the image in the background. So if you create the background node and if you call for some image, then there will not be any background, black background. There will be some different background. You can call the image from the image file. Now the biggest problem is that how to adjust the pivot point of imported index faced object. That is the biggest problem in this particular exercise, and that is the biggest trick also. The 3ds file created from AutoCAD will create the biggest problem for pure center. Without pure center, it is very difficult to rotate the object. The perfect pure center can be located with the help of viewpoint, because viewpoint will align itself to the center of the frame. By default, viewpoint aligns themselves to the center of the object. Delete most of the unwanted viewpoints. As I have deleted all the 6 viewpoints, so delete most of the unwanted viewpoints except one that you want as a pure center. Find out the deviation from the non-zero coordinates of viewpoint and assign exactly opposite value to the object. Assign exactly opposite value that of object to the pure center or same as the viewpoint. Now it will be very difficult to understand this particular thing, but if we can demonstrate it by means of video, then you will easily understand what I am going to say. So actually we will be bringing our pure center to this viewpoint, and now you can see that these are the white lines which are crossing. These are representing the 0 0 0, perfect absolute 0 0 0, and the viewpoint is at perfectly absolute 0 0 0, as well as the frame is also at 0 0 0. So viewpoint is perfectly at the crossing point of the two white lines. The object is equally distributed on the both sides of the crossing line. Now you can lock x and y axis to see that object is perfectly rotating about the pivot center. So this is how you can guess that whether your object has came perfectly at the center of the pivot point or not. This is the test. So we will demonstrate how to locate perfect viewpoint center. So first of all, we will open the Vivaty Studio. Now our objective is to bring the pivot point perfectly at the center of the frame. So we will import the frame. Okay, then there will be some viewpoints, default viewpoints. I will delete most of the viewpoints. This procedure I have explained earlier also, and I will keep only one viewpoint which is of most importance to me, because I want to rotate the entire frame around this viewpoint. So I want to bring the pivot point at this red spot, and you can see the white lines are crossing with each other and my frame is not perfectly distributed around the white lines. So this is the deviation of the viewpoint from 0 0 0. I'm just copying that deviation into the notepad. Simply I am copying this value of deviation to the notepad. This is the deviation in the x-axis. This is the deviation in y-axis. This is the deviation in y-axis. Now I have selected the index face. Now I will move the frame exactly to the opposite of, exactly by the opposite values. So if it is plus 0.35735, so it will be minus, and here it is minus 6111, so it will be plus. Opposite will be plus. I will be moving the frame exactly in the opposite direction. My objective is to bring the entire frame so that it will be equally distributed on the white lines. And now you can see that my frame is equally distributed along the white lines. Now I will bring the viewpoint exactly at the center. Now the viewpoint is perfectly at the center. The frame is perfectly at the center. Now only I want to move the pivot point at the center. So for that pivot point, I have to move the pivot point in such a way that it will come to the center. Now exactly by the same value, I have moved the pivot point. Now you just lock the X and Y axis and try to rotate. Lock the X and Y axis. I'm locking the X and Y axis and just try to rotate the frame. Now you can see that it is perfectly rotating about the red point, which is viewpoint, or we have moved our pivot point to this point. Now it is perfect. So such type of rotation that we want. Okay. Now we will be creating touch sensor and time sensor. Create touch sensor. Then create time sensor also. So we have created the touch sensor and time sensor, and the trigger node is time sensor 1. So this will be our trigger node for all the frames. Now next step is animating the square frames for a period of 10 seconds. So we will be animating the square frames for a period of 10 seconds. So at 5 seconds there will be a snap rotation of 179.909, and at the end of 10 seconds, it will be 359.817. So we will delete the keys at 2.5 and 7.5 seconds. Those are not required. So I'm just going to animate this frame. I added the animation node as the index frame. Now we will go to the animation timeline. I want to delete the keys, so that's why I have activated edit key fraction. By edit key fraction you can delete the key. Again I am switched over to edit keyframes. Now I am moving the slider to 5th second directly. 5th second, I will be moving the slider to the 5th second. And at the end of 5th second, the snap rotation will be 179. So that I have already copied in one text file. I'm just pasting it. Press enter. Then move the slider, animation slider, to the 10 second and paste the next value, that is 359.817. That's all. Now you just check whether the frame is perfectly. It should complete 4 rotations within 10 seconds. That is required. So that completes the animation. Now we will be duplicating the frames without touch sensor. Frame has to be duplicated at a distance of 0.4 on z-axis, minus 0.8, minus 1.2, minus 1.6, minus 2, minus 2.4, minus 2.8, and minus 3.2 on z-axis. Instead of frame duplication, try to duplicate the entire group. That will be better. Remove the touch sensor from the group. If group do not permit color change of individual frame, then try to convert the group into pickable group. There are various types of groups. In that, there is one category called as pickable group. You convert it into pickable group. Saving and reopening the file can also serve the purpose. If it is not permitting the color change of the individual frame, then you can try this. So we will be duplicating the group 8 times without touch sensor. So first of all, I will create the group. Now bring that group to 0 0 0, perfect 0 0 0. Now you just bring that group under the main group, and we will be bringing this time sensor, touch sensor, and index, all these three under that group. Now I will duplicate this group several times, means 8 times. Now this group will be moved along the z-axis. I'm actually moving it along the z-axis minus 0.4. Delete the touch sensor is not required. Now you make a multiple copies of this group 2 several times, maybe 7 times. Now I have added trigger, that is time sensor 2. By default, time sensor 1 will be my trigger. Now we will check. Now if I click on the first frame, second frame is also moving. It means that my animation is perfect. Now I can go for making multiple copies. Again, shift this group by minus 0.8 second. Add trigger. Okay. This is a quick preview. Everything is fine. We can make multiple copies. It will be minus 1.2. Minus 1.2. It will create fourth frame. Make another copy. Minus 1.6. It has created another copy. So there are 5 frames now. Then minus 2. It will create 6th frame. Minus 2.8, and This will be the last frame at 3.2 minus 3.2. Okay, this will be the last frame. So we have created 9 square frames. Now we will be adding the trigger to the touch sensor. We have already added a trigger for time sensor 1, 2 and 3. Now we require time sensor 4, 5, 6, 7, 8. So from 4 we have to add to the trigger. This is time sensor 4. Okay. Then time sensor 5. Time sensor 5. Then time sensor 6. Then time sensor 7. Time sensor 8. And time sensor 9. That's complete. Now just check 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the time sensors have been added into the trigger. By default, our trigger point will be time sensor 1. It will trigger all the time sensor. Now in this particular step, we will be increasing the animation time. It will be 11 seconds. For time sensor 3, it will be 12 seconds. For 4, it will be 13 seconds. For 5, it will be 14 seconds. For 6, it will be 15 seconds. For 7, it will be 16 seconds. For 8, it will be 17 seconds. For 9, it will be 18 seconds. I'm just have a cross check, and I think everything is correct. So from 10 seconds, it is progressively increasing. Now here we will be coloring the frames into different color. Now select the groups, select the index face tag, actually index face, select different colors. Do different colors to all the frames. You can create materials also, and you can define the colors within a particular say shade. That will be creating more wonderful effect. Instead of assigning the color randomly, you can choose the color from a specific color shade, range of colors from the color shade. In the last, I have defined one material. So we have given the color. Now just check and examine whether our animation is working or not. Yes, it is working. First frame is moving fast, second is little bit slower, third is more slower. So we are getting the required effect. Now here we will be checking out the final output. Just save the file with some name. I have selected the name as rotating color frames. Then export this file to your say desktop in Vrml format. And now we can open this particular file in our DS contact layer. And this is the required output. So our objective was to create these kind of rotating frames, and we have created. The animation is perfect. You can view it from different angles, from top, from bottom, in isometric view. And it is as per the expectation. So thanks for watching my video. In case of any query or clarification, you can contact me on my contact details. You will get the code in the description as well as in the comment box. Thank you.